Hello everybody, this is Problem 123 again, and today we're gonna see this problem from CSAcademy named tree coloring, in which we are given a tree with n nodes and a number k, and we should paint every node in one of the k available colors. We have to count the number of ways of painting the tree such that any two nodes are a distance 1 or 2 are painted in different colors. In the first line we have NK, and the next n minus 1 lines are gonna be the tree description. Okay, so how are we going to solve this problem? Well, this is actually a permutation problem, but a tricky one because we are working with graphs here. Okay, so let me explain to you what is happening with this. Of course, we're gonna use the graph editor resource that we have here in CSAcademy as well. This is a very great thing. Okay, so let's say we have a graph from 1 2, then from 2 to 3, from 3 to 4, and from 4 to 5. Okay, and we're gonna try to put them in a straight line. Okay, I think it's arranging itself. Well, if we start to paint from vertex 1, it is clear that we have k colors available for this vertex. Okay, but what happens with vertex 2? We have one color that we have already put here, so we cannot repeat this color. So we have k minus 1 colors available for vertex 2. So we have k minus 2, k minus 2. Okay, I mean k minus 1 colors available. Okay, but now we have vertex 3 that is connected with vertex 2. Vertex 2 is already painted and vertex 1 is already painted, but since we need those vertices that are distance 1 or 2 painted in different colors, we don't want to repeat the same color as vertex 1. Okay, so for vertex 3 we're gonna have k minus 2 different options. Okay, but what happens when we come to vertex 4? Well, we don't care at all. We have the same k minus 2 colors available for vertex 4. Why? Because vertex 4 is a distance 1 from 3 and a distance 1 from 2. I mean a distance 2 from 2, and it has nothing to do with vertex 1. So we only care about 2 vertices here, okay? And in vertex 5 we have as well k minus 2 colors available. So the answer for a graph like this, that is a line graph, but it is not noticeable right now. Let me just arrange it so that you see it. Okay, we click here and those become static nodes. Okay, so basically the answer for a graph like this, a linear graph, is gonna be k minus 1, I mean k times k minus 1 times k minus 2 times k minus 2 times k minus 2. Okay, but it is not enough for us to know this. It is a good approach, but it is not enough. Okay, because we are not going to have line graphs when we approach this problem. So let us think about this graph right here. We are just going to copy the input and we're gonna put it here. And here we have another graph that is weird right now, but we're gonna arrange it so that it becomes clear. Okay, blah blah blah. Okay, yeah. Okay, that's the graph that we have for this example, and we know that the answer is 48. So we have 4 colors available. Okay, so basically the approach to this problem is start painting whatever node you need, whatever node you want. Okay, and for that node you're gonna have always k colors available. Okay, so let's say we start from node 1. Okay, so when we expand to node 2 and node 5, we are gonna have, well, Let's begin from one of those. Okay, so let's say node 5, for example. If we start from node 5, well, we're gonna have like a 4 minus 1, which is 3. So we have a value of 1 for vertex 1 and a value of 3 for vertex 5. Okay? But what happens here with vertex 3? We have no longer 3 colors for it because we have already used 2 colors for vertex 1 and vertex 5 for painting these two nodes, and we cannot repeat them. So this vertex 3 can only be painted in 2 colors. For vertex 2, it can only be painted in 1 color because we used 3 colors here, and vertex 2 is at distance 2 from all of them. So we can only use 1 color. Oh, wait, what was not the edge? Okay. We can only use 1 color for vertex 2. Now for vertex 4, well, it is just connected to 2 nodes with distance 2. It's only connected to 2 nodes, so we have 4 minus 2 colors available. That's 2. Okay. So in total we will have 4 colors for vertex 1 times 3 colors for vertex 5 times 2 colors for vertex 2 times 1 times 2, which is the number of colors for this side of the graph. We're going to have a total of 48. 4 times 3 is equal 12, times 2 is equal 24, times 2 is equal 48. Okay, so basically for every node, the result of its children, every of its children times itself, it's gonna be the answer for that node. So we have to just compute the answer for vertex 1. But it is important for you to see this. We have from root k-1 colors available for the first vertex, but for the second vertex we have k-2, for the third vertex we have k-3, and so on. So for example, what happens here if we add another edge, let's say to 6? What happens with that edge? Okay, what happens is that if I have already assigned a color to vertex 4, we have only one possible color for vertex 6. Okay, vertex 6 is connected to 1, 2, 3 nodes, okay, with distance 1 or 2. So I have 3 colors that I cannot use, so I can only have 1 extra color for 6. And what happens when we add another edge, let's say to 7? What happens here is that I have a total number of colors of 0. I can only paint that vertex in 0 colors because it is already connected to 4 nodes. So I have no color to paint it, and this is gonna give me a total answer of 0 when it gets back to node 1. Okay, so that's everything we need to know. Let's see the code for this problem. You can also see this code in GitHub. I have posted it in my public repository. Okay. Remember that we have to compute the answer modulo 10 to the power of 9 plus 7. Okay, so what we're going to do is that we are gonna initialize our graph. We're gonna read our n and k. We're gonna put the values in the graph, and we're gonna call, and we're gonna print the answer for node 1. And we are passing this parameter k. You're gonna see why. Let's say that the fs function, this is actually a short code. This parameter ball is gonna tell me which value is gonna be assigned directly to the node. how many colors can I paint that node in, okay? So our current answer is gonna be ball value, and here we have a variable count that is gonna tell us the number of prohibited colors, okay? At first it's 1 because I cannot repeat my color to my children, so I have 1 prohibited color. And if I have a parent, my children cannot have the same color as my parent. So I'm gonna increase by 1 the value of count. And this condition is gonna be false when we first call the DFS with root. This condition is gonna be false, but for all the other nodes, it's gonna be true, okay? It's just to differentiate the root from the other nodes, okay? You can also say here if u is different from root. Well, it's just a condition to check if it is the root, okay? I assign the parent of p to be u, and I'm gonna multiply my current answer times DFS in position v, and I'm gonna pass the parameter of k minus count. And I'm gonna increase the value of count as I move in my list of children. Because remember, all my children are gonna be a distance 2 from each other. So I don't want to repeat colors. That's why I am increasing this variable, and then I subtract it from k, and that's the value I pass to my children, and I get the modulo of that answer, and that's it. I just have to return ends, and that's how this code works actually. So I hope this video was useful for you. This is everything we need to know about this problem. I have given you in the description the link to this problem and to the solution, the code that I have just shown you. Thank you for watching, and remember to share this video with those who need it. See you in another video, and bye bye.